Let's find the equation of the tangent line of f of x, which is x cubed plus 2x plus 1, at the point 1, 4. And so we remember from algebra that anytime you need to find the equation of a line, what you need there is this formula. We say y equals m times x minus x naught plus y naught, where x naught, y naught is your particular point and m is your slope. Okay, so in terms of tangent lines, we can say that that's going to be your m tan times x minus a being your initial x coordinate, plus f of a, which is your initial y coordinate. And we can even take it a little bit further and saying that we know how to find m tan through this thing we call the derivative. So that can be f prime of a, f prime at a, which is your tangent line, your derivative at a times x minus a plus f of a. Okay, so that's your equation of your tangent line. And so we can see this is a two-step process. One, can you find f prime of a? And then two, can you find all of this? Okay, so we'll work through both of those. Okay, starting out with 1, we look to the definition of the derivative. So the derivative at my x coordinate 1, because that's the point I'm dealing with, 1, 4, is the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Now as it stands, I cannot plug in 0 for h, right? Because then I get 0 over 0. So I actually have to do a little bit of work here. It's not too bad though. So what does f of 1 plus h look like? That's 1 plus h quantity cubed plus 2 times 1 plus h squared plus 1. All of that minus f of 1, which is going to be 1 cubed, plus 2 times 1 squared, plus 1, all over h. And sometimes it's useful to identify your parts. So here, all of this right there is f of 1 plus h, and this right here is your f of 1, in case you're wondering. Okay, now from there, I can do some expansion on this using something called Pascal's triangle. And so I can say that this is the limit as h approaches 0 of, how do I expand out this 1 plus h cubed? Well, again, it's through Pascal's triangle. It'll look something like this. It's going to be 1 plus 3h plus 3h squared plus h cubed. Okay, and then you have the 2 times 1 plus h squared. So that's going to look like 2 plus 4h plus 2h squared. I have plus 1. And then here I have minus 1, minus 2, minus 1. And I didn't bring those together on purpose because I want to show something here. So notice now that I can subtract, I have a 1 minus a 1 there. Oops, right here actually. I have a 2 minus a 2. And I have a 1 minus a 1. Okay, so now when I bring all this together, I have, let's see, I have a 3h plus a 4h gives me a 7h. I have a 3h squared and a 2h squared, that gives me a 5h squared. And I have a 1h cubed all over h. And now notice there's an h in every term. So I can cancel out my h's, and I'm left with the limit as h approaches 0 of 7 plus 5h plus h squared, which now when I plug in 0, I get 7. And so there's my derivative at 1. So remember, don't forget, this is your m tan. This is the derivative at 1. That is the slope of your tangent line. Now we're ready to move on to the second part of this, which is actually finding your tangent line. So again, remember, your tangent line is the derivative at 1 times x minus 1 plus f of 1. Okay, well, I already have some of this stuff. We just calculated m tan to be 7. We have x minus 1. There's nothing to be done there. And f of 1, we can either plug it in, but they gave it to us. That's just simply 4. Right, we got it right at the beginning. Okay, so now just simplifying this, we end up with an equation of the tangent line being 7x minus 7 plus 4. So then that means that my tangent line is 7x minus 3. And there's the equation of my tangent line. I hope this makes sense. If you need help, look up how to use Pascal's triangle. There are some other examples where algebra can be kind of weird. If you need any help, let me know. I'd be glad to help. I'd be glad to show more examples. Thank you for watching. All right.